Hi dears, I hope exercise 2.1 will be clear for you all. If any doubt, please post it in the comment section. And in this video, we are going to discuss exercise 2.2. And first question, find the zeros of the quadratic polynomial and verify the relationship between the zeros and coefficients. So first subdivision, x square minus 2x minus 8. We will do by factorization method and coefficient method. So first by factorization method. So for factorization method, we will be multiplying this constant and the x square term, isn't it? So minus x square, 8x square. We need to split into two numbers in such a way that product is minus 8 and the sum or difference is minus 2. Since we have minus in the second term, so this has to be, the greater number has to be minus. So minus 4x plus 2x. So x square minus 4x plus 2x minus 8 equal to 0. Then we combine these two terms and next two terms. So x into x minus 4 plus 2 into x minus 4 equal to 0. So x minus 4 into x plus 2 equal to 0. So when we equate separately the factors to 0, we will get x is equal to 4 and x plus 2 equal to 0, x is equal to minus 2. So this is by factorization method. And by coefficient method, before that we'll just add the zeros. Okay, so the sum of zeros is 4 plus of minus 2, so minus 2, it is 2, and product, it is 4 into minus 2, that is minus 8. Okay, so by coefficient method, take the coefficients of x square, x and constant as a, b and c. So coefficient of x square is plus 1, coefficient of x is minus 2. You need to take the minus also. And constant is minus 8. And we know the formula for sum of zeros. Either you can write sum of zeros or alpha plus beta. That is, the formula is minus b by a, that is minus of minus 2 by 1, minus into minus, it is plus 2. And product of zeros or alpha into beta, that is c by a, that is minus 8 by 1 minus 8. So we get sum of zeros as 2 and product of 0 as minus 8. Therefore, the relationship is verified for the question x square minus 2x minus 8. Second subdivision, 4s square minus 4s plus 1. So first by the factorization method, we equate to 0. The same like the previous question, we will multiply constant and s square term. So 1 into 4s square is 4s square. So here in between we have minus. So product is plus means both the numbers should be negative or positive. As we have minus, we can write it as minus 2s minus 2s. So 4s square minus 2s plus 1. And when we combine these two, it is 2s minus 1. And here we can take minus 1 as common. And we get 2s minus 1, 2s minus 1. So the values are equal, isn't it? So 2s minus 1 is equal to 0, 2s is equal to 1 or s is equal to 1 by 2. So we get both the values are same. So when we add the sum of zeros is 1 by 2 plus 1 by 2, the denominator is same. When we add the numerators 2 by 2 or 1. And the product is 1 by 2 into 1 by 2, numerator into numerator, denominator into denominator, that is 1 by 4. And by the coefficient method, the coefficients of s square is 4 and s is minus 4 and constant is 1. The formula is, for the sum, it is minus b by a, that is minus of minus 4 by 4, 4 gets cancelled, minus into minus is plus 1. And product, it is c by a, that is 1 by 4. If you check with the values, the sum is 1 and product is 1 by 4. They are equal. Therefore, the coefficients and the zeros are verified. Third subdivision, 6x square minus 3 minus 7x. First, for factorization method, we will rearrange in decreasing order. So 6x square minus 7x minus 3 equal to 0. Now if you check with the product, constant and x square term, minus 18x square. So we need to split into 2 and in between minus sign and product is also minus. So it is minus 9x plus 2x. So I'll write 6x square plus 2x minus 9x minus 3 equal to 0. So we can take 2x as common, then that will be 3x plus 1, and we can take minus 3 as common, so that will be 3x plus 1, and taking 3x plus 1 as common, we have 2x minus 3 remaining. When we equate to 0 separately, 3x plus 1 equal to 0, so 3x is equal to minus 1, x is equal to minus 1 by 3, and 2x minus 3 equal to 0, 2x equal to 3, x is equal to 3 by 2. So when we add these two, the sum of zeros, minus 1 by 3 plus 3 by 2. So when we take the LCM, it is minus 2 plus 9, it is 7 by 6, and product, it is minus 1 by 3 into 3 by 2, 3 gets cancelled, we get minus 1 by 2. And by coefficients method, we'll write what is A, that is coefficient of x square is plus 6, coefficient of x is minus 7, and constant is minus 3. Now, the sum of zeros is formula minus b by a, that is minus of minus 7 by 6, minus into minus plus. And product of zeros, alpha beta c by a, that is minus 3 by 6, we can cancel here. Final answer is minus 1 by 2. When you check with these zeros, the sum 7 by 6, product minus 1 by 2. As they are equal, the relationship is verified for this question. Fourth subdivision, 4u square plus 8u. Here if you see, we don't have constant term, so that is 0. For factorization, we take 4u square plus 8u is equal to 0. As we don't have constant term, we can take u, and for the numbers we can take 4 as common. So 4u when we take common, it will be u plus 2 equal to 0. When we equate separately, 4u equal to 0, so u plus 2 equal to 0. So when we equate this, we get 0 by 4, 0. Here u plus 2 equal to 0, u is equal to minus 2. So when we add, the sum of zeros will be 0 plus of minus 2, it is minus 2, and product 0 into any number is 0. And by coefficient method, the coefficient of x square is, here it is u square, so 4, and u term it is 8, and constants we don't have, it is 0. By formula, the addition of zeros, alpha plus beta is minus b by a, so when we substitute, minus into plus is minus by 4, so when we cancel, it is minus 2. Same way the product, alpha into beta, it is c by a, that is 0 by any number, we get 0. When we check with the sum, it is minus 2, product, it is 0. The relationship is verified. Fifth subdivision, t square minus 15 equal to 0. For the fourth subdivision, we don't have constant. For this subdivision, we don't have the t term, that is the middle term. When we factorize, t square minus 15 equal to 0. This we can express as a square minus b square form. So 15 is not a perfect square. So we can write root 15 the whole square. If it is perfect square, whatever the number, we can write that number the whole square. Now this is of the form a square minus b square, and we know the formula a plus b into a minus b. So it is t plus root 15 into t minus root 15 equal to 0. So t plus root 15 equal to 0, when we equate separately, we get minus root 15, and t minus root 15 equal to 0, when we equate separately, we get t is equal to root 15. And when we add these zeros, we get minus root 15 plus root 15, both the numbers gets cancelled, so it is 0, and product, as it is of the same number and the square root, so square and square root get cancelled, we get 15, plus into minus is minus 15. And by the coefficient method, the coefficient of t square is plus 1, we don't have the middle term, so it is 0, and constant is minus 15. And formula for sum of zeros is minus b by a, so it is 0 by any number, 0, and product, it is c by a, that is minus 15 by 1, minus 15. When you check with these zeros values, sum of zeros is 0, product is minus 15. Hence the relationship is verified. Sixth subdivision, 3x square minus x minus 4. When we factorize, minus 4 into plus 3x square is minus 12x square. So product is minus and in between also minus sign. Yeah? So one number has to be minus. So minus 4x plus 3x. So 3x square plus 3x minus 4x minus 4 equal to 0. When we combine these two terms, we can take 3 as common. So 3x, x plus 1. Here we can take minus 4 as common. So it is x plus 1 equal to 0. So x plus 1 is common. 3x minus 4 equal to 0. When we equate separately, x plus 1 equal to 0. X is equal to minus 1. 3x minus 4 equal to 0. So 3x equal to 4. X is equal to 4 by 3. When we add the zeros, the sum will be minus 1 plus 4 by 3. When we take the LCM, it will be minus 3 plus 4. That is 1 by 3. And product, plus into minus is minus 1 into 4 by 3 minus 4 by 3. And by the coefficient method, A value is the coefficient of x square is plus 3, B value is the coefficient of x is minus 1 and the constant is minus 4. The sum of zeros, alpha plus beta, formula is minus b by a, that is minus of minus 1 by 3 plus 1 by 3. And product, that is alpha into beta, it is c by a, that is minus 4 by 3. When you check with the values, sum of zeros is 1 by 3, product is minus 4 by 3. The relationship is verified. Question number 2. Find a quadratic polynomial each with the given numbers as the sum and product of its 0 respectively. So, they have given the zeros. We need to form the quadratic polynomial. 1 by 4 minus 1 they have given. The sum of zeros as 1 by 4. Product as minus 1. Either you can compare with b by a, minus b by a and c by a, or we have the formula x square minus sum of zeros into x plus product of zeros equal to 0. When we substitute x square minus 1 by 4 into x plus of minus 1. First we substitute, then we multiply the minus and plus inside. So x square minus x by 4 minus 1 equal to 0. When we take LCM, it is 4x square minus x minus 4 the whole by 4 equal to 0. When we cross multiply, it becomes 0. And the required equation is 4x square minus x minus 4 equal to 0. Or 4x square minus x minus 4. Second subdivision, they have given the sum of zeros as root 2 and product of zeros as 1 by 3. When you substitute in the formula, we get x square minus sum of zeros into x plus product of zeros equal to 0. So here x square minus sum of zeros is root 2 and product is 1 by 3. When we take the LCM after multiplying minus and plus inside, it is 3x square minus 3 root 2x plus 1 the whole by 3. When we take 3 to the other side, when we cross multiply, we get 0 on the right side. So 3x square minus 3 root 2x plus 1 equal to 0 is the required equation. Third subdivision, they have given the sum of zeros as 0 and product of zeros as root 5. So when we substitute in the formula, x square minus sum of zeros into x plus product of zeros equal to 0, we get x square minus 0 into x plus root 5 equal to 0. Here we don't have fraction, so LCM is not necessary, and 0 into any number is 0. X square plus root 5 equal to 0 is the required equation. Fourth subdivision, both they have given 1, that is alpha plus beta also they have given 1, sum of zeros, and product of zeros, alpha into beta also they have given 1. When we substitute in the formula, x square minus sum of zeros into x plus product of zeros equal to 0. So here x square minus 1 into x plus 1 equal to 0, or x square minus x plus 1 equal to 0. If it is not in fraction, LCM is not required. Fifth subdivision, minus 1 by 4 and 1 by 4, that is the sum of zeros they have given as minus 1 by 4 and product of zeros they have given as plus 1 by 4. When you substitute in the formula, x square minus sum of zeros into x plus product of zeros, we get x square minus of minus 1 by 4x plus 1 by 4 equal to 0. Here we have the fraction, so we need to take the LCM. So 4 will be the LCM. So 4x square minus into minus 1 into x plus 1 the whole by 4, and we take the 4 to the right side, so 0 into 4 is 0. So 4x square plus x plus 1 equal to 0 is the required equation. Sixth subdivision, they have given the sum of zeros as 4 and product of zeros as plus 1. When we substitute in the formula, x square minus sum of zeros into x plus product of zeros equal to 0, we get x square minus 4x plus 1 equal to 0. This is the required equation.